All right, so today we're talking about the volume of prisms and cylinders. I'm going to consider these to be the same thing because really you have a cylinder being a regular polygon with an infinite number of sides and it following all the same area and perimeter rules, and that's a whole separate conversation. But the moral of the story is we find the volume the same way. We can use one formula for all these. So big question is first, what's volume? So volume is the amount of 3D space that an object occupies, or another way to look at it as the amount of 3D space enclosed by the container, because the container itself is a two-dimensional and infinitely thin, there's no thickness to it, space, like a blanket or something. So it's just what's held inside or how much space the outside takes up, either one. Now, a question would be, like, I just built these and took a picture of them. What's the volume of these? Okay, now you might go ahead and you might count them up. I've heard a lot of clever ways. Like some people said, well, I see this as this is a box, right? A rectangular prism, where then some rectangular box here in the middle has been removed. And that was like, that's so cool. That's such a cool view, you know? I had other people say, you know what? I saw it totally differently. I saw it as a 2x3 here, a 2x3 here, and a 2x3 here. So I saw 3 groups of 6. That's awesome. I love that, okay? Another way that you could do this, and this is the way we're going to talk about today, is you could count up this one layer right here and then say, well, there's 1, 2, 3 copies of that same layer. And the same goes for this other one. Some people cleverly said, well, I could move this into there and get a rectangular box. Or another person said, well, I know these are all groups of 4, so I could just count up 1, 2, 3, 4, 5, 6, 7, 8 groups of 4. Well, I'm going to say doing basically the exact same thing. We could just count up this one front shape and then say, well, I've got 4 copies of that because I have 1 layer here, 2 here, 3 here, and 4 here. So 4 copies of this front shape. And so I take the area of that front shape and I multiply it by 4 layers. So to kind of look at the big picture, if I wanted to count up the number of seats in this bleachers, I'm not going to sit there and count each one, right? I'm going to come up with a more efficient way. And that more efficient way is saying, well, I just count up 1, 2, 3, 4, 5, 6 in this direction. And then I'll just say, well, how many of those do I have? I have 1, 2, 3, 4, so on. And I would multiply this number 6 in one row by how many rows I have. And so I wrote that right here. I'm not going to count them all. I'm going to count how many there are on one row and then say how many duplicate rows do I have? How many of that exact same row do I have going down? Okay, well, we're going to do the same thing with volume, okay? So if I want to figure out the volume of something, I'm just going to say how many cubes are there in one layer, and then I'm going to multiply it by the number of layers, right? So I'd say in this front layer, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there are exactly 2 layers. So I'm going to say, well, then the number of cubes that make up this space are 2 layers times 20 per layer. And so that gives me a total of 2 times 20, or a volume of 40 cubes. Whoa, 2 times 20, where did I get the 20? I'm sorry. That was 10 per layer. So 2 times 10. I'd already done the multiplication in my head. So each layer having 10 times 2, we get a total of 20 cubes. Okay? That's how we're really going to look at volume. Find one layer's area and then multiply it by the number of layers. Okay? So here's a couple more practice ones. The first thing you need to do is identify which side is the base that gets projected through identically. So this is a prism. This has 4 plus 3 is 7. And that's 9, 10, 11. So there's an area of 11 on the front. And I know I've got 1, 2, 3, 4 layers of 11. So I'm going to say, well, I take that area of 11 and my volume would be that area of 11 times 4 layers. And so my total volume would be, there are 44 cubes, assuming there's no like missing cubes in the back, or, you know, assuming that pattern continues as we assume it does. In the second one, you can't choose this front as a base because it doesn't go through all the way. It stops. Instead, you'd have to choose this side as the base and then say it goes all the way through for 4 layers of the same shape. And so we count this up. We go 1, 2, 3, 4, and we get, okay, there's a 11. So the area of the base is 11. And so we'd say the volume then is the area of the base times how many layers there are. So the volume would be 44. Okay. So next one, same thing. We'd say there's, counting is hard. 1, 2, 3, 4, 5. And 6 is 11. And 2 more. So that's an area of 13. And then we have 4 layers. And so we have the volume would be that 13 cubes on one side times 4 identical layers, or volume of 52. Okay. So down here is the official formula we'll use. I accidentally wrote surface area when I made this. So this is the formula we're going to use. Essentially what we're saying is that the volume of any prism or any cylinder, which is one shape projected through space to the exact same shape on a parallel plane, we're just going to say, well, that's equal to the volume of, or the area of the base. And that area of the base is kind of like our one layer, right? And then the height of the prism is really our number of layers. So we'll say, okay, so how many squares are there in our one layer on bottom? That's the area of our base, right? The area of a two-dimensional base shape. And then the height is, well, how many layers of that do we have? Do we have 2 copies of that layer? Do we have 20 copies of that layer? So the area of that base shape times the height, or the distance between the bases. Okay, so let's just go through some examples, okay? So first off, some open-ended questions here. In what type of units is the volume? Well, that would be some area of the base, right? The area of the base would be in something like inches squared times the height, and we get in cubic inches or in cubic feet. So it's in spatial 3-dimensional units. It's how many cubes would fit in there. Now it might be a fraction of a cube because a fraction round things, but how many cubes of water could I fit in there when I splash it in? This question is really cool, and I don't want to rush you through this. I would recommend pausing the video here and thinking about this before I explain it. So 2 solids have the same surface area. Any 2 solids, a round one and a square one, any 2. Do they have to have the same volume? And then explain. I don't care if you say yes or no, right? That's not the important part here. The important part here is the reasoning. So I've had a couple people think of this in really cool ways. Okay, now some people are like, well, you know, what if we start with some original shape and we say, okay, it has some volume, right? We say, okay, keeping the same surface area, if we make it shorter, then that means it has to get wider, right? For it to have the same amount of surface area. It's saying you're building it with the same amount of wood. If it's not as tall, it's got to get wider. But the question is, would they have the same volume? I don't know. I mean, it is getting shorter in one dimension, but wider in another dimension. Is that more or less liquid in it or not? That's hard to think about. So I had one student say, well, think of equilateral triangle that's 4 by 4 by 4. Now this is 2-dimensional, but you said that's got a perimeter of 12, and this over here is a square that's got a perimeter of 12, right? And then she even expanded it to say, what if it was a rhombus of 12, right? All these have the perimeter of 12, although this one's got an area of 9. This one's got an area of something with the square root of 3 in it once we split it in half in 30, 60, 90 triangles. And then this one over here, the more we tilt that rhombus, the smaller and smaller and smaller the area gets. And so she said, well, it's analogous to that in 3 dimensions. You know, we could think of it being the same. If we're restricted to the same surface area, does it have the same volume? I said, awesome. Another student, which was awesome, said, well, what if I take the same shape, right? And on one, I have, let's say it's a cone. I have a cone sticking out. Okay, that's surface area is the lateral area of the cone plus the yada yada. Okay, well, what if we take the exact same surface, but in the other one, we have the cone sticking into the shape. So just convex, well, that's not convex, but that one part being convex sticking out, and this being concave sticking in. This isn't a convex shape because there is an indent here. But just having a bubble sticking out or bubble sticking in. It's the same amount of material and yet more or less volume. So that's the answer is no, just for that counter example. Another way to think about it is a Ziploc bag. If you take two of the exact same Ziploc bags, it's the same material, same surface area, but you could blow in one, fill it up with air, and the other one you could remain flat and close it. So that doesn't correlate that they have to have the same volume. So that's a really cool question. I like that one. Okay, so I'm just going to go through a bunch of examples. We got time here. The lesson's done if you want to stop and go and practice on your own. So I've seen a lot of ways to solve these problems. So I'm going to solve all three of these in three different ways, okay? So one way is a student said, well, let's just cut this up, okay? I'm going to cut this up to be two things. I'm going to say the top one has a volume, let's call it V1. The bottom one has a volume V2. And I'm going to say the total is the V1 plus V2. Okay, that's how I'm doing number 4. Okay, so just figuring this out, I've got V1 here. It's a rectangular prism, so I'm going to say the area of, let's choose this as my base. And then for the next one, let's choose this as my base. Okay, so for V1, the area of that base is, I got to figure this out. There's a 1 down here at the bottom, so 1, 1. So there's a 2 by 1. So the area of that top rectangle is 2 times, and the height of that rectangle, which would be the distance from base to base, is 3, right? 3 over here. So times the height of 3. Plus, and then the volume of the bottom one, I chose this to be my base. So again, I've got an area of that base is 1 times 2, or 2. And then the height of this prism would be the distance between the bases, or 7. So the total volume here is the volume of the top piece, or 6 cubes, plus the volume of the bottom piece, 14 cubes, or a total of 20. Okay, and you could have counted this. You could have said, well, this is 1 deep, so every single one of these I can see, and this is 2, so I cut it in half by 3, so there's 6 there, and then this is 2 by 7, and then you just cut it up like this, and you could just go ahead and count. That's 1, 2, 3, 4, 5, 6, so I need one more cut. There we go. So and then you could just count the cubes. So for the second one, I'm going to say this is actually a prism. I can tell this is a prism because it's the same polygon on one side projected through to the back. So I'm going to say the volume is the area of that base times the height. So the area of that front base, I'm going to have to figure out in 2 pieces. I'm going to say one area is a 4 by 1 rectangle, and one area is a 5 by 1 rectangle. So I've got 4 times 1 plus 5 times 1 being the area of the base, or the area of the base being 9, right? And that's that front side, or that front face being the base of this prism. And then I'm going to say, well, what's the height of this? And this is where a lot of people make a mistake. They go, oh, top to bottom, 6. But that's not the height of a prism. The height of a prism is from one base to the other. The base in this prism is the shape T, that upside down T there. So the distance from one base to another is a distance of 2. So the height of this prism is 2. The height of this prism is 2. So the volume here would be 18. And I found that by saying, what is the area of my base shape, where this is my base, okay? And then times, and then this dimension right here is the height, because it's the distance between the bases. Now for 6, I'm going to do it even differently. Instead of adding 2 together, or instead of saying this is a prism, although it is a prism, here's your base, and then your height would be 4. But instead of doing it that way, I'm going to say, you know what? I see this as actually, there was an original shape here. There was one big rectangular box here that was like this. It was a perfect rectangular box, and some person came in and just chopped pieces off. Cruel. So I'm going to call this let's call the whole thing as V1, the like big total thing. And then I call this V2 and this V3. So I'm going to say the total is that V1, the big thing, minus, and that is all of it, including the stuff I'm taking away. That's the entire rectangular prism. And then I take away this little V2 and little V3. All right. So the volume of the big rectangular box, this would be a 5 by, now there's a 3 plus this extra little 1, so this would be a height of 4 of the base. So of this entire rectangle, I get the base of that is 5 times the height of 4, so that's 20. Let me switch to blue here. Times, and then from base to base is another 4. So we go, okay, so times 4. That's my big one. So I've got, that's 80. Okay, and then I'm going to take away my 2 little volumes. So I took from this original 80, I took away a 1 times 1, depth of 4 cubes, right? So I've got a 1 by 1 on front, and then it's 4 deep. So that is the area of the base, 1 times 1, times the depth of 4. And on the other side, 1 times 1, depth of 4. So minus 1 times 1, depth of 4. So we've got the entire thing used to be 80. Then we cut off a volume of 4 from one corner, cut off a volume of 4 from another corner. And so we get a total volume here of 72. So 3 different ways to find the volume of these. Whichever one you're more comfortable with, go with. If you want to double check a problem on a test, you could do it 2 different ways and see if you get the same answer. Okay. Now it gets to slightly more complex things. So the first thing, again, when you're looking at a prism or something, you need to identify the base. So in 7, the base has to be the triangle. This is not a rectangular prism. This rectangle in front does not project through space the same. It shrinks down to a single line in the back. So that is not a rectangular prism. This is definitely a triangular prism. So the volume is the area of the base times the height. So the area of the base is going to be 1/2 base times height. That's the area of a triangle times, and the height of this prism is the distance between the 2 triangles, or 5. Okay, so now I just got to work out. So the total volume then is in the base, 1/2. And in that triangle, if I draw it out, the triangle looks like this, 7, 10, and right angle. So the area of that shape is 1/2 times 7 times 10. That's the area of the base. That's the capital B. And then times the height of the prism is 5. So that is 1/2 of 70, or that's 35, times 5, which is 150, 175. Okay. The next one is a rectangular prism. So when it's a rectangular prism, any side could be the base. You could think of this one being projected through, or you could think about this one being projected through. For no apparent reason, I'm going to choose that side. Okay, I'm going to say then the volume is the area of that base times the height. I know that the area of a rectangle is base times height. And the height of my prism is the distance between the bases. That's 4. Okay, so in my base, I have 2 times 1.5. So the area of my base is 2 times 1.5. And then times the height of the prism is 4. So that's 2 times 1.5 is 3 times 4. So I got a volume of 12 here. Okay, last one over here. Now this one's going to be a little harder, so I'm zooming in here. So again, you have to identify this right away. This is a prism with a hexagon as a base, and it's projected backwards. So the volume is the area of that base times the height. So the volume is, now this is a regular prism. So this is a regular hexagon as a base. I'm going to go, this is 1/2 AP. Now you could cut this into equilateral triangles or something, but I'm going to treat it as a regular polygon. So 1/2 apothem times perimeter is how you find the area of a regular polygon. And then I'm going to multiply it by the height is the distance between the bases. So that's 18. Okay, so now I just got to work out how I get this other. I'm going to switch to a smaller size here. So I've got a hexagon that's regular. So I'm going to cut it and say, all right, well, that gives me a side of 7.5. And then in central angle here, when I look at this, I go chop, chop, chop. I get 1, 2, 3, 4, 5, 6 triangles. So there's 6 sides. So 360 divided by 6 symmetrical triangles, I get a central angle of 60. And in fact, this is a isosceles triangle, which means it's an equilateral triangle. So I get 7.5 on all sides, 7.5, 7.5. So all I need to do is find the apothem, or the height of that triangle right here. That's the apothem of my shape. So what I get is, I get a 30, 60, 90 triangle, where this is half of 7.5, or 3.75. This is 7.5. And then I've got to find this apothem over here. Now I'm going to use 30, 60, 90 triangles just because I like it. I say, so this is similar to 30, 60, 90, 1, 2, and root 3. So I can see there's a clear multiply by 3.75. So this is 3.75 root 3. So going back over here, I get that this is 1/2. And then I'm going to use the times 3.75 root 3. And then times the perimeter. Now the perimeter of that base is that side 7.5 times 6. So I'm just going to write that in here for now. 7.5 times 6. That's my perimeter. This was my apothem. And then times 18. So that's the volume. Now to simplify this, I'm going to leave the square root because I like exact answers. So what I'm going to do off to the side is I'm just going to say, what is 1/2 times 3.75 times 7.5 times 6? Okay, and then I want to multiply that one more time. So I want to multiply that by the 18 out there. And so I get that number. That's an exact number. Okay, so 15,187.5. So 15,187. So that's 15,187.5 root 3. And that's my exact volume. If you want to plug in the root 3 and get an approximate, that's great. Okay. Now, again, the difficulty there was what's the area of the base. Once you do that, you say, oh, times the height of 18, we're done. But the trick was finding the area of the base. And that's going to be really common. That's the difficult part. Okay, we could also have this with circles. So again, still, I'm going to say I really think this is a prism. It's a shape projected through space. Because it's a curve, it's not technically a prism. It's a cylinder. But I'm going to say this is still the area of the base times the height. Well, the base shape is a circle, so the area of the base is pi r squared. I know the height is the distance between the circles, so it's 12. So it's pi 7 squared times 12, or pi times 49 times 12. I don't know what that is off the top of my head, so I'm going to say 49 times 12, which is 588. So the volume of this is 588 pi. And again, I like exact answers, so I'm going to leave it like that. Over here, same thing. You get volume is the area of the base times the height. Now the difference here is that the area of the base, because it's pi r squared, does not use the 10. Still, distance between the bases is clear at 16. But now the radius is not the 5, or it's not the 10. That's the diameter. So we need to divide that by 2 and say this is pi 5 squared times 16, or pi 25 times 16. And I know 4 25s make 100, and 4 4s make 16, so I know this is 400 pi. And again, I like exact answers, okay? So let's look at another one here. So this says, describe and correct the error and find the volume of a right cylinder. So a right cylinder would be a cylinder standing upright. It says the area, it says the radius is 4. It says the height is 3. So I know volume would be base times height, or pi r squared times the height is 3, or pi 4 squared times 3. Let's see what they did. Oh yeah, they used 2 pi r instead of pi r squared. So they were finding the circumference times the height. And if you guys remember from our work before, if they find the circumference, which is a length, and multiply it by height, what they essentially did is they unwrapped this shape to be a rectangle, where this is 2 pi r, or the circumference, and this is the height. So what they did is they found the lateral area. So what they did is found the lateral area of a cylinder by multiplying that circumference times the height, length times the height. They found a 2D area, and it happened to be the lateral area of the cylinder. But we wanted the volume, so they should have used the area of the base times the height. So anything we do forwards, we can absolutely do backwards. So if we know how to find the area, we could plug in our formula, even if there's a variable, and then say, well, I know out comes a certain thing. So here's the first one, straightforward, it's just a cube. So we know that the area of the base, oof, that was rough. The area of the base is x times x, using the bottom as the base. So the volume would be base times height, or x times x. The height would be the distance between the bases, or x. So I know that the volume is x cubed. And it tells me that the volume is 1,000. That's equal to x cubed. So all I would do is on my calculator, I would take the cube root, saying what number to the third power is equal to 1,000. And we get x has to be equal to 10. And that's something you could plug into your calculator. But the cube root of 1,000 is saying what to the third power is equal to 1,000. It happens to work out nicely, but another problem, it might come out as a decimal. That's totally okay. All right, so assuming this is not circular and this is rectangular, we could find it either way. Now, shoot, that would be... I'm going to assume they imply this to be a nice triangle. I mean, we're also ignoring all these divots and holes and wedge stuff. So let's... Now, I mean, we could for sure find the area of a sector and then multiply it by the height. Like, whether it's a sector or a triangle, it's not that much different. I'm going to assume they meant this to be a triangle, okay? They were not clear on a test or quiz. I would be clear. So what we want here is 9 and 9. We need the volume is the area of the base times the height. Shoot, you know what? Let's think of it both ways. So if it's an isosceles triangle that's 9, 9, and 5, we need to cut it in half. So we get a 2.5 and a 2.5. And we use Pythagorean theorem to find the height. And then we go the area. This is 1/2 base times height. But instead, I'm going to say it's a wedge of a circle. I just think that's more interesting. It's a more beautiful problem. So what we've got here is we've got... Man, this is a cool problem then. So let's do this. Let's just get into it. The bell's going to ring here in about a minute. So we know the height of this is the distance between these, or x. So we're going to say this is times x. Now, what we got to figure out is what chunk of the circle do we... Oh, I shouldn't use x. We need like w. What chunk out of 360 degrees do we have? Because that fraction of pi r squared is what fraction of circle we've got. So let's figure this out down here. Well, out of a total circumference of 2 pi 9, 2 pi 9, that's the total circumference of the circle, we have 5. So we need to figure out how many degrees is that. So out of 360, what number of degrees is this? I called it W, okay? So I'm going to figure out of 360 degrees, what do I have? Now, if you're really being clever, does it matter which fraction we use? Does it matter whether we use the fraction of degrees? Or couldn't we just use the fraction of circumference? So rather than solving for W, if we know W over 360 is the same fraction as this, let's just replace it. Now you could, if you're more comfortable, if you're like, I just want to use the formula. I don't want this free thinking. First of all, that's disappointing. But second of all, you could... Wait for the bell. You could go ahead and solve for W. Cross multiply, find W, put W in, everything will cancel out backwards. But what I'm going to do is I'm going to say all we care about is what fraction of circle do we have. So the fraction of circle we have is 5 out of a total circumference of 2 pi 9 times pi 9 squared, and then times that. That's our total volume. So let's see what happens. Well, a pi and a 9 cancel with a pi and one of the 9s. So we get 5 over 2 times 9 times x equals 45 is the volume. So just simplifying this, this is 45 equals 45 over 2x. And then I'm going to multiply by 2 on both sides just to get rid of that 2. So I get 90 equals 45x. Divide both sides by 45. And we get x equals 2. Man, that was a fun problem if you're looking at it like a circle. If it was a triangle, the way you'd find the area of the base is, again, just splitting that isosceles triangle in half using Pythagorean theorem and so on. So I'm going to pause for a second. I'll come back and do 4 more examples in a little bit. Hope you're enjoying the videos so far. Okay, seconds for you have passed, but a few hours for me have passed. Sitting back down. Let's go on and solve one last one here for x. We've got, I'll do this in blue again. Why not? Let's change it up to green. So we've got the volume of this prism, which is technically a cylinder, but I like to think of it like a prism because there's one shape being projected through. We've got the volume is the area of the base shape times the height. We know the distance between these bases here is 8. So I know that height is 8. So I'm really going to find the area of the base here, which is pi r squared, okay, equals 8, or times 8, sorry, equals the total volume, okay? So now let's plug in what we know, okay? So I'll stick in green here. We know the end resulting volume is 128 pi. X is our diameter, so 1/2 of x would be our radius. Now this is going to get a little fraction heavy, but pi, and then I'm going to call this x over 2, or 1/2 x squared, times 8. So that's 128 pi equals pi times, now if you square both these, x over 2 times x over 2, you get x squared over 4 times 8. So canceling, I'm going to put that 8 over 1 and multiplying. These reduce to a 2. So what I get is 128 pi equals pi times x squared times 2. Now I'm going to divide both sides by a pi and a 2, or 2 pi, which will cancel out the 2 and the pi in one fell swoop. And so what I end up getting is 128 divided by 2, or 64, is equal to x squared. So, whoa, not dividing. Square rooting both sides, I get x equals 8. Now, technically it'd be plus or minus 8, but obviously as x is a diameter, it has to be a positive length. Okay, so last ones, we've got composite shapes here. Now, you've got a couple different ways to do this. Now, one way is I could say, oh, you know what? I've got the volume of a big cylinder, and I'm going to take away the volume of a little cylinder. Now, that's one way to do it. I like to be a little more, whoa, Cypress, what was I spelling there? So I like to be a little more creative here, and I like to think of this as a prism, or a prism-like thing, where there is one shape being projected through to the same shape on the other side. So I still see this as volume equals the area of the base times, and again, the height, the distance between the bases is 7. So I still think of it as one single base projected through to the other side. And then what's the area of that base? Well, the area of the base is going to be a pi r squared of the big. Maybe let's use a capital R for big. And then minus pi little r squared. Because we're going to find out big circle's area. And then we're going to cut out a little circle's area. So let's do this. I'll stay in blue. So we've got the volume is equal to, and in this parentheses, I've got pi times small or big radius squared minus pi times small radius squared times 7. In other words, that's 9 pi minus 1 pi, or that's 8 pi times 7. So in other words, the volume is 56 pi. Okay. Now for the second one, I'll do it through subtraction. Okay, so again, you could think of this like one base shape, find the area of that, and then times, it goes all the way through, times the height, and you get the volume. But I'll do it a pretty common way is people say, let's find the volume of the big and take away the volume of the small. Okay, so as though this were a solid shape, I'm going to say, what's the volume of this whole box? So I'll choose the top as the base. So volume is base times height minus little base times height. So of the big one, I've got this side 7.8, this side 12.4. So I've got 7.8 times 12.4. That's the area of the base shape times a height of 9. And now I'm going to subtract the little one. Now the little one has length and width of 1.8 times 3. That'd be the area of that little one times, and it's got the same height, 9. So now to the side, just to avoid doing the decimals myself, we got 7.8 times 12.4. Okay, and then times 9. So the volume of the entire shape is 870.48. So 870.48. And then I'm going to cut out that hole. I'm going to say, okay, so there is actually a hole, so we're going to have to subtract 1.8 times 3 times 9, and that's going to be 48.6. So 48.6. Now I'm going to, I already have that, so let's cross it all out. So we got 870.48 minus 48.6. And that gives us 821.48. Or was that 88? Or was that 88? Sorry, not 48. 88. Okay, let's do one last one. Now, this last one I'll do again my way. You absolutely could go volume of box plus 1/2 volume of cylinder. That's probably the most common way. So that would be base of the box times height, plus 1/2, and this would be the area of the base times height, or 1/2 pi r squared times height. Absolutely, you can do that. But you know what? Instead, I like changing it up. I like seeing this as a prism-like thing where it's got one face that is projected all the way through. So I'm just going to find the area of that face and then use its volume as that face times the height. So I'm going to go ahead and say the area of that face is, it's a 4x4 rectangle or square plus half a circle. So that's 1/2 pi, and the radius is 2 squared. That's the area of this. So I did, just to erase up here, I did, this is 4 times 4 to find this area. Okay, so 16. And then for the other part, I said, if I want to find this area up here, I did 1/2, and a radius must be 2. So 1/2 pi 2 squared. Okay, so that's the area of my base, and then times the height is from that shape projected back to the backside, 4. And so from there on out, it just becomes simplification. So this is 16 plus 2 squared is 4. 1/2 of 4 is 2 pi. And then times 4, I'll distribute that in, and I get 64 plus 8 pi. And you can't simplify that any further, so that's the exact answer. Okay, I hope you enjoyed that video. Good luck on your own.